My dear students, today we will learn about cylindrical coordinates. This is part of section Curvilinear coordinates. As a first lecture in this section, we learned about spherical coordinate system. Now we have to discuss cylindrical coordinates. Okay? Here, the cylindrical coordinate system is also a three-dimensional system whose coordinates are S, phi and Z. Okay? S, phi and Z. Z is the same z-axis which is defined in the Cartesian coordinate system. Phi is the same azimuthal angle which is defined in spherical polar coordinate system. S is a new variable which is defined as distance from z-axis to the point P. Okay, so I think I can draw here the figure. See, this is the Cartesian coordinate system. X, Y and Z. Okay, in this system, suppose there is a point P somewhere here whose Cartesian coordinates are X, Y and Z. Okay, I can show here the point is somewhere here. The point is shown here. This is P. Okay, point P. This point P is at a distance S from Z-axis. Okay, a distance S from Z-axis. Okay. Now, this angle is phi. The angle between this S distance and x-axis. This is phi. Okay. These are the coordinates which is defined in cylindrical coordinate system. That means the Cartesian z-axis is the z-axis. Phi is defined in between this and this phi azimuthal angle. This is same as S. S is the distance from z-axis to point P. Okay, in the spherical system, we define the variable such that it is distance from origin to the point P, position vector. Okay, origin to point P. But this time in the cylindrical coordinate system, the first variable S is the distance from z-axis to point P. Okay, the same distance obtained here also. Okay, in this plane. So phi is the angle between X and S axis. Okay, so I can write here Z axis just like Z axis as same as in Cartesian coordinate system. Okay, Cartesian coordinate system. Cartesian coordinate system. Okay. Now the S phi angle azimuthal angle. Okay, azimuth angle. Here this angle is defined as angle between X and S axis. Okay. Angle between X axis and S. This angle. And P from z-axis. Okay, distance to point P from z-axis, this is S. These are the three variables in the cylindrical coordinate system. As we learned earlier, here this system is more useful when the system has cylindrical symmetry. Okay, so these are the main variables S, phi and Z. The coordinate system is orthogonal curvilinear coordinate system. Okay, orthogonal curvilinear coordinate system. So now we can take further the unit vectors. So you can see that here this is the point P. I can show here the direction. The S cap is along this increasing S, direction of increasing S. This is the direction of S cap. Now phi cap. Phi cap is along this direction because we are rotating along like this, counterclockwise direction. So phi cap is along this direction. This is phi cap. And Z cap is like this. Okay, this is Z cap. As along the Z direction, along the increasing Z, this is the direction of Z cap. These are the three unit vectors which can see in this cylindrical coordinate system. S cap, phi cap and Z cap. Okay, I think now we can write the unit vectors, these three unit vectors, S cap, phi cap and Z cap in terms of Cartesian coordinate system. Okay, so I can write here as first of all we know that Z cap is the same Z cap which is defined in Cartesian coordinate system. Okay, so we can write first Z cap equal to Z cap itself. This is the same Z cap which is defined in Cartesian coordinate system. Okay. The next one is S cap, right? S cap. How can we write S cap? As all of you know, this is S cap. We know that this S is along this direction also, okay? So, taking its component along these two directions, you can see that cos phi is along this and sin phi is along this. Okay, so cos phi along this. So, you get cos phi x cap plus sin phi y cap, right? Sin phi y cap. This is the component of S cap in terms of the basis vectors of Cartesian coordinate system, x cap and y cap. Okay? Now we want to write phi cap, right? How can you write phi cap? Phi cap. Phi cap is given by Z cap cross S cap. Okay? Cross product of these two. Z cap cross S cap gives you phi cap. So Z cap cross S cap. So you will see that Z cross X, Y cap, right? Okay. So Y cap cos phi. I can write here Y cap cos phi. Then Z cross Y. Z cross Y means minus X cap, right? So minus sin phi X cap. Okay. Minus sin phi X cap Y cap plus cos phi. Okay, I think I can write it here. Minus sin phi X cap plus cos phi Y cap. These are the unit vectors. Similarly, sometimes we need to transform one coordinate system to another. The components of vectors from one coordinate system to another. So similarly here also you can transform the relation between these Cartesian variables and cylindrical system variables. So we can check it here. I already told you Z is same as our previous Z. Okay, but S is equal to X. X is equal to S cos phi. S cos phi. Similarly, Y is equal to S sin phi. This is the connection between Cartesian coordinates and cylindrical coordinates. Okay, S cos phi, X equal to S cos phi, Y equal to S sin phi. Z is equal to Z as we already learned. Okay, similarly you can find out the inverse relationship also. If you want to find out S, you can see that S square equal to X square plus Y square. Right? S square equal to X square plus Y square. Similarly, if you take this tan phi, you will get Y by X. Okay, so phi equal to tan inverse Y by X. Inverse relations, you can write from here itself the inverse relationship also. Okay, so these are the main important points in connecting with the cylindrical system. Next, we want to define its scale factors or length elements and volume element, etc. Okay, so just remember all these things. We can write the length elements in different axes. Okay, so in this system, the length element dl is defined as dls s cap plus dl phi cap plus dlz z cap. Okay, we already learned that. Yes, phi and z are the different coordinates in the cylindrical system, and s cap, phi cap and z cap are mutually orthogonal basis vectors in this system. Okay, now dls is equal to, dls is the length element along the increment of s. It is same as ds. Okay, this is ds. Then what about dl phi? dl phi, the length element along this dl phi is given by s d phi, arc length. Okay, s d phi, just like we defined in spherical system, where there we defined r sin theta d phi in the spherical system. This time the s played role of r sin theta. Okay, so s d phi. Then dlz is equal to dz itself. Okay, so you get dl equal to ds s cap plus s d phi cap plus dz z cap. This is the length element, infinitesimal displacement vector in cylindrical coordinate system. Similarly, you can write the volume element d tau. Okay, volume element d tau. Volume is dls into, volume element is given by dls into dl phi into dlz. This is equal to ds s d phi dz. Okay, this is the volume element. Okay, you can write this as S dz dz d phi. This is the elementary volume element. Okay. Now we can write the gradient and different differential operators in this cylindrical coordinate system. So the gradient operator. Suppose we want to find out gradient T in cylindrical system. For that I take a subscript Cy here, gradient T. So here you can see that this is given by S cap dou T by dou S plus phi cap dou by S dou phi T plus Z cap dou T by dou Z. Okay, this is the gradient operator in cylindrical coordinate system. Now we can write the divergence operator. Okay, divergence. So del dot V, the divergence is operator is given by dou by dou phi V2 plus dou by dou Z is V3. This is the divergence in cylindrical coordinate system. Here we assume that this vector V such that vector V is equal to V1 S cap plus V2 phi cap plus V3 Z cap. Okay, then you can write like this as V1 and dou V2 and then dou by dou Z of SV3. Similarly, you can write the curl in this coordinate system, curl. That means del, then I think I can write this del cross V. Okay, del cross V. So here you can write this as the first component is along S cap into dou by dou phi. Okay, then V3 minus dou by dou Z V2. Okay, so this time here scale phi S is also SV2. This thing whole divided by S is also here. this plus. Next component is phi cap. Okay. Now to get phi cap, you need first write dou by dou z, right? Dou by dou z. Dou by dou z of V1 minus, okay, dou by dou s of V3, okay, dou by dou s of V3, this plus, next component is z cap, all divided by s is always along with all components, okay. The third component, to get z cap you need dou by dou s, right? Dou by dou s of V2. Along with V2 there is a scale factor S2. Okay? SV2 minus dou by dou phi V1. Okay? This is the curve in this cylindrical coordinate system. Okay. Now you can write Laplacian operator here, substituting for component of vector v. Okay, for vector v, you have to write this component dou t by dou s, all these components. Okay, so you can write its Laplacian operator. I think I can write it here. Like this. So here already there is gradient t. So you want to write this term also. So you have 1 by s dou by dou s of s into, instead of v1 you have to write this term dou t by dou s. Okay. The next one is dou by dou phi, instead of v2 this term. Here there is s, so you have to put it here also. So you have 1 by s dou t by dou phi. Okay. Similarly, this plus the next component is dou by dou z. Okay, dou by dou z and s into v3. So you have to write v3. v3 means this one, dou t by dou z. Okay, so this is the Laplacian in cylindrical coordinate system. These are important points you have to remember. I think you can get an idea of about this cylindrical coordinate system. Okay. Now I think I can wind up this session. So here, before winding up all these things, I just give you some extra tips to remember all these coordinate system and its differential operators. Okay. That means this is not mandatory for your examination point of view, but if you want to do more problems related with this, you maybe get confused. You can avoid this using these things. For example, we can generalize these two coordinate systems. That means all these Cartesian or cylindrical or spherical coordinate system in a broad class, orthogonal curvilinear system. Okay, orthogonal curvilinear system. Okay, I don't want to go to details of this coordinate system, but I will give you some tips. For that, let U1, U2, U3 are the different axes in this curvilinear system, orthogonal curvilinear system. If this is Cartesian system, this is equal to x, y, z. If this is spherical system, this is equal to r, theta and phi. If it is cylindrical system, this is goes to s, phi and z. Okay. Now, we can corresponding to this, there are basis vectors. Okay. Basis vectors. These basis vectors, I can organize this in another way. For example, coordinates. Okay. Basis vectors or unit vectors here. Then scale factors. Scale factors. Using these things, you can write any differential operator in this spherical or cylindrical system. Okay. For that, the first one is, let us U1, U2 and U3 are the coordinates. Okay. Then its corresponding basis vectors are U1 cap, U2 cap and U3 cap. Okay. So the corresponding scale factors are H1, H2, H3. Now you can compare this with Cartesian system. Okay. So for Cartesian system, the coordinates are x, y and z. And the basis vectors are x cap, y cap, z cap or I, j, k. And when you reach here, you have 1, 1, 1. That is why you write here dx, dy, dz. Okay? There is no coefficient for this dx, dy and dz. So these are all coefficients are 1. Scale factors are 1. Okay? But when you move it to, this is for general orthogonal curvilinear. Okay? Orthogonal curvilinear system. This is for Cartesian system. Okay. Next one is spherical system. Spherical system. There you have r, theta and phi. Okay, r, theta and phi. Here the basis vectors are r cap, theta cap and phi cap. Okay, and then the scale factors are 1, then r sin theta. Okay, so you can see that though these basis vectors are unit vectors, these are not, the coefficients are not constant, because theta cap connected with this r and phi cap connected with this r sin theta, etc. Okay, so these are called the scale factors. This is the scale factor for phi. So in order to get the length element, you have to multiply this with d phi. For that, this with d theta. This is the same dr. Etc. Like that. So these are the scale factors for the spherical system. When you speak about this cylindrical system, there we have s, phi and z. Okay, corresponding to this s cap, phi cap cap. And here scale factors are 1, S and 1. Okay. So S d5 is length element here, ds here, dz itself. Okay. These are the summary of this coordinate system. So now using this knowledge, you can generalize all your gradient operators in terms of this. That means gradient operator in this system. It is u1 cap by h1 dou by dou u1 plus u2 cap by h2 dou by dou u2 plus u3 cap by h3 dou by dou u3. Okay, this is the gradient operator. Similarly, you can write the divergence operator here. Okay, del dot v, divergence operator. Then you have here one by h1, h2, h3, all the scale factors multiplying. Then inside this you can write first divergence goes over dou by dou u1. Okay, inside this you have the scale factors, these two, h2, h3, v1. Okay, then dou by dou u2, but this time except these two, the scale factors h1, h3, v2. Okay, next comes this plus dou by dou u3, h1, h2, v3. Okay, this is the divergence operator in this system. If you replace h1, h2, h3 and u1 with the corresponding variables, you will get this operator in the corresponding system. If you replace h1, h2, h3 with the cylindrical coordinates and the coordinates with this r, theta and phi, you get corresponding divergence expression for divergence. Okay. Then I think I can write curl, del cross v. Del cross v. Okay. Here del cross v u1 cap by h2, h3. Then inside, not to get u1 you have to differentiate with u2 and u3. Okay, so you have to first write dou by dou u2. Okay, dou by dou u2 of h3 v3 minus dou by dou u3 of h2 v2. This plus u2 cap h1, h3. Okay, this plus dou by, in order to get u2 cap you need 3 cross 1, right? So do dou by dou u3 first. Inside this h1 v1 minus dou by dou u1 inside this h3 v3. Okay, now u3 cap by H1 H2. Okay, inside this dou by dou U1 H2 V2 minus dou by dou U2 H1 V1. Okay, this is the expression for curve. Similarly, you can write the Laplacian operator also. There you have to substitute just for this V1 from here. Okay, instead of V1, you have to write this term H1 dou by dou U1. Then you get corresponding Laplacian operators instead of V1, instead of V2, instead of V3, etc. Okay, so simply knowing these curvilinear variables and the scale factors, you can write all the differential operators using this expression. Okay, so this is a tip for remembering the conversion of cylindrical and spherical coordinate system and its corresponding vector differential operators. Okay, now I think I can wind up now. This is a very small section. Here we learned about cylindrical coordinate system. In that system, we see that the S, phi and Z are the variables. S is the distance from Z axis to the point P. Phi is the azimuthal angle. Z is the same as the Cartesian Z axis. Then we write the length elements and volume element, all these in cylindrical system, and the corresponding different vector differential operators also. Okay, so learn well. Thank you.